Welcome to Photonics in Focus, the podcast where industry leaders and innovators share insights into the latest advancements in integrated photonics technology. Join us as we explore how this emerging technology is transforming industries and driving new possibilities, and how AIM Photonics is at the forefront of this revolution. Tune in to stay ahead of the curve in the rapidly evolving world of photonics. In this episode, we delve into a critical aspect of integrated photonics manufacturing, advanced packaging technology. Leah Scott, AIM Photonics Director of Communications and Information Management, leads a conversation with Chris Striemer, Director of Test Assembly and Packaging Operations, and Mark Wagner, Operations Manager at AIM Photonics TAP facility in Rochester. They'll discuss the innovative test assembly and packaging capabilities that AIM Photonics offers, highlighting how it supports customers' unique prototype development needs. This support is crucial for companies aiming to enter or remain competitive in this rapidly evolving industry. So whether you're an innovator designing your first integrated photonics prototype or a company scaling up for production, AIM Photonics is ready to help with our comprehensive end-to-end manufacturing and packaging solutions that address your specific needs.
Chris, Mark, welcome. Let's jump right in and talk about some of the challenges companies can face when transitioning from concept to prototype. There's design complexity and ensuring prototypes are production ready. So how does AIM Photonics, and more specifically the work being done at TAP, address these challenges and support the entire development process?
So I would say that, the work we do here at TAP, is basically the part of the prototyping process where the innovator, our customer, has already, completed their designs. They've gone through the AIM Photonics MPW program, or potentially has made their own wafers through our offering, through the Albany Nanotech facility at New York Creates. And wafers come here to the TAP facility. We're not just a packaging facility in the traditional sense of just putting chips and assemblies together, but we also have 300 millimeter processing capability here. So we have a fully functional bumping line. And so, the work here at TAP really starts at the bumping step, where essentially you're taking the planar aluminum termination pads that are on a typical wafer that comes out of the fab, and we're building up additional metals, additional ways of interconnecting, the downstream process, after the wafers are singulated. And so, that bumping process involves full photolithography. We can deposit metal, thin metal seed layers. We do plating, obviously coding, developing, all that stuff, all the way through to dicing. And then after the dicing process is done, that's how the wafers become individual chips. And then we have, chip level processing, which is the flip chip technologies that are out there for, doing metal interconnects between chips themselves. We have precision alignment and gluing capabilities for what would be die attached to, say, a circuit board or another package, whatever. We also offer wire bonding capabilities in addition to you can either flip chip's one technology of electrical interconnections between chips where you can do very, very high densities using that bumping process that I talked about before. Another approach is to, wire in more of a singulated serial fashion with wire bonding. And we can also attach fibers, which is kind of the nature of, AIM Photonics. That's the photonic side of our packaging. And then we also offer all the metrology services that support those efforts. And we work very closely with the customer, to make sure that we provide the necessary data that they're interested in acquiring from their prototypes. We do everything possible to ensure their success. We usually don't have a ton of parts to work with. We do the most that we can with the parts that we're given. The most important thing is just to work closely with us. That's the benefit of working with a manufacturing innovation institute like AIM Photonics is get involved with us early. We want to talk to you early. We want to correct those problems before they work into your design. And then that makes it a whole lot smoother of a process once your chips are ready, are finally fabricated and make their way to TAP. And I'm sure Mark would, has more to say about that since he has to deal with these challenges.
Yeah, so I usually work with the customer on their details. So I think your question was, how do you go from concept to prototype reality? So in the conceptual stage, it's usually a sketch, a little 2D sketch. Boxes tend to go together really well in PowerPoint or something like that. But when you're building in in reality, there's a lot of details to address. So one of the things that's interesting in the photonics space is, in a lot of cases, they talk about packaging taking about 80% of the cost. So since AIM Photonics has an MPW program, there's a lot of mature processes for creating your PIC. But what do you do when it comes to packaging? And the reality is, at this stage, it's kind of custom. And the packaging industry has always been fairly custom for each design. So we can do something standard for customers. Most prototype customers go through a standard flow of, we get their PICs, we'll do a die attach onto a printed circuit board or some other substrate that they design. We'll do wire bonding if it's an active PIC, and then we'll do active align fiber attach. And so there's details associated with all of those steps that we have to go through. We have some standard design guides that help them go through that process. But sometimes we get some kind of more unique designs. And the neat thing about TAP is we have a lot of fancy tools, a lot of new tools in advanced packaging. And so we can help them figure out how they might be able to incorporate their product into a design that's more advanced and more, suitable for long-term manufacturing.
We know emerging technology development doesn't always rely or operate on standard solutions. Can you share some examples of the unique test, assembly, and packaging capabilities that make AIM Photonics particularly well suited for advancing integrated photonics and prototype manufacturing?
I'll just take the example of the bumping line that we have here. Traditionally, we don't just process wafers that come out of the Albany fab. We often will work with wafers that come out of, general fabs from across the country or actually internationally. And we've encountered, several cases where, particularly at the prototype level, there really, in a lot of cases, is not a solution for people that have contracted with a fab, have gone through an MPW run of some kind for an electronic chip, state-of-the-art chip. There's really no good option for bumping in the U.S. And in many cases, there's no good option for bumping anywhere in the world because they only have 2, 3, 4 wafers. That's a very specialized service, and at 300 millimeter, it's very, very rare to be able to have this capability to build up these thick metal features, these fingers that kind of reach out and create these bumps that allow this interconnection to happen. And so we've actually worked with a couple customers where they had no option except for us to work with AIM, because we understand that in the prototyping phase, you don't have the benefit of volume. And we also know that, even there are some packaging facilities out there that will go at risk and do a small number of wafers, but with the promise that it's going to grow exponentially and, into an economic level or to a sales level that moves the needle for them. And then the trouble is the next time you go back, if you haven't, attained that level, that they won't talk to you. Whereas here we understand, not all prototyping is a straight line. You don't always, hit this hockey stick and very quickly, get to a final state. And so we're willing to process single wafers. In some cases, if we can figure out a way, to even process pieces of wafers. And there are cases, and we have methods here, that if you haven't even thought about bumping and you already have your chips and suddenly you want to do a flip chip process, it's like we will go out of our way to come up with a way to make that successful. And we've done that several times in the past. So that's a good example of things that we try to do, even though that is an avoidable problem, with advanced planning. We understand that, with schedules and, with limited resources, you get into situations like that. And we do everything we can to make our customers successful.
So what comes to mind to me is photonics packaging is in the field of advanced packaging, where you're trying to assemble small parts of different types of technologies. So, for example, we will do precision alignment of lasers onto PICs in some projects. Even our standard fiber attach process is a pretty precise process where we have to align to submicron features. So that's something that's a bit unique in that we're working in submicron alignment type of applications for photonics, which gets to a bigger point of where the overall semiconductor industry is headed. Heterogeneous integration is something that the entire industry has been focusing on, this kind of more than more type of approach. And, TAP has a lot of those tools in place, and we're expanding our tool set right now. So I think we're in a good position to help people outside of just the photonics, even if you're looking at advanced assembly. That field itself, the photonics industry, I mentioned putting lasers onto PICs and putting multiple different chips onto silicon cytosubstrates. This is where the industry is headed. As opposed to putting a bunch of individual packages onto a printed circuit board, you put a bunch of chips onto a more tightly integrated silicon or other kind of substrate. So we're involved in all of those type of operations.
So I heard someone at a conference talk about TAP and say, we do weird well.
Mm-hmm. Absolutely. That's what, that comes down to the fact that we are in the prototyping field. We see lots of strange stuff. We see lots of mistakes that somebody, didn't intend to happen, but they, have now spent, 6 months waiting for chips that have invested quite a bit of time, in the designs. And they really need to get something out of it, even though there might be a mistake that interferes with their ability to do that. And we do everything we can, using the tool set that's available, to, extract something from these sorts of builds. Whether it's, post-fabrication modification with focused ion beams and different deposition techniques, or whether it's using, some sort of novel, chemistry to clean a surface off, or to, establish an interconnection with, instead of wire bonding, maybe using gold studs or, mixtures of different solder eutectics to enable somebody to actually allow us to get that assembly together, into a point where it's, you can get the data. So that's the weird part of it. So that's the weird aspect of it. And I'd like to think that we do it well because of the fact that, we have all this capability here, and we really want to be able to, and it allows us to put, to design processes and create new approaches that a standard packaging fab might not be able to do.
Some of this weird stuff comes from the fact that packaging is often an afterthought in the design phase. So there's a lot of effort that the designer's putting into designing their chip. And they're probably exhausted at that point. And they're just like, I'll figure out the packaging later. But the good designs do have the packaging up front, especially when we're talking about optical assemblies. So a little word of warning: if you want things to go smooth, maybe weird is not your best approach.
So once a prototype is successfully developed, scalability often becomes the next hurdle for some companies. What are some of the strategies that TAP uses to help customers move seamlessly from prototype development to scalable production?
So part of it is how we work with customers. So the simplest case is there's a design or some small project that a customer wants us to work with them on. We can do that. We'll set up an agreement with you to do this specific project. Another thing that we can do, since we're a nonprofit institute, we work with people on services agreements. We can set up an open services agreement. And what this is once you have this agreement in place with us, you can come to us and, do a little bit of work in metrology, try some things based on the results of that in an assembly operation, and keep doing iterations with us. You can work with our engineers to kind of go back and forth with this type of approach. So we can, in some respects, be an extension of your engineering team. Certainly we have a facility that's expensive, that's available, that's at your disposal that we can help you with. And so I think that's something that's pretty unique that we offer that it's hard to get access to. I think most manufacturing service companies are really interested in volume. What we're interested in doing is helping customers get their product to market, get them to a stage where it's gone into production. We certainly have a facility that can get you into low or maybe medium volume production, depending on what you want to do, and then work with you to transition it if your product is successful enough to go into high volume.
And I guess I'll just add to that the fact that one of the benefits of working with AIM Photonics, especially at the TAP facility, is that as a Manufacturing Innovation Institute, we try to use production relevant equipment. We're not always, we didn't cheap out on, very, very small prototyping level equipment. We have this is a real facility with real 300 millimeter capability, quite a bit of automation. And, as Mark had said, we're capable of scaling, to meet the needs that a customer would have to do to kind of bridge that valley of death in the manufacturing process and get to a level where there would be interest for another follow-on manufacturer. We're not out here to put anybody out of business, in terms of the scale up. When a process is ready to be transferred into the private sector, it should transfer to the private sector, and we'll do everything we can to facilitate that transfer.
And we also, with our programs, we're willing to work with other manufacturers as well. And we actually encourage that, other manufacturers that are U.S. based that are doing assembly related work. This is another facility. They can try out some new things with some of our advanced equipment to decide, is it even worth investing in this new tool?
And also, we're not, I think a lot of our customers are surprised at how open we are, in terms of our processes. We have standard processing flows that we've developed, with the public funding that we've received, and we're happy to share that with people, the base flows. And so we're not here to have secrets. We're not here to be siloed. We're here to share the information we have, to share process information with folks. And if when a customer gets to the point where they're reaching into territory that is more proprietary, we're happy to facilitate that as well. And we generally ask that we can maintain standard processes here. And then if a customer wants us to develop something proprietary, we can work something out, with them at that point. But we can get everybody to a certain level of understanding of our processes, and and in that sharing, get them to the point where they're empowered to go to the next level and work with other contractors, or work with us in a higher level capacity. And I will say here, this is probably a good forum to discuss that we're also working on a facilities access model, that will allow customers that have dedicated projects. So it's not individual processes that they want to do, but those that have dedicated processes that use several of our tools. We're willing to be able to train people up on the use of those tools and get under the right circumstances, get them to the point where they can develop their own processes and as extensions from what we're doing. And we view that as a tremendous offering, to the community, because, typically these small or mid-sized companies can't invest in the type of equipment that we have here, and making it available to help them. Again, we're here to bridge that valley of death, get them to the next point. And I think that's a value that we offer to the ecosystem.
So that approach literally is, as long as it's qualified, TAP can serve as a manufacturing site without you setting up a manufacturing site.
Oh, that's great. Could you share an example of a recent prototype or innovation technology development that highlights TAP's capabilities and benefits?
So we have certainly prototypes that have come through with assemblies that are going into the telecom industry. We have a few projects that are in the sensor space for both vapor and biological sensors. I can't name the name of the companies, but there's a lot of potential to put these products in the field for medical diagnostics, for example. So those are later stage examples. We have some other assemblies that we've worked on that's more akin to, we'll call it traditional optical assemblies, where they're using our PICs to significantly lower the cost of laser test type of equipment. So there's a number of different applications that we've been working on with customers.
Well, that's great. Having access to test assembling and packaging capabilities plays a pivotal role in having integrated photonics manufacturing. What would you say is the best way to begin collaborating with AIM Photonics or TAP directly on projects?
Typically the interactions that we have with customers start from the inquiry page on our website. You go under service offerings, the TAP comes up fairly easily to find, and you can submit an inquiry. That gets you into our record system, gets your particular interest exposed to, tens of people, and we follow up on all those inquiries. Alternatively, if you've interacted with any of our staff, a lot of times people interact with us at conferences or different other shows. We give out our cards all the time. We have customers that are out there that spread the word, of what we do here, reaching out to us directly. Anytime that a customer has a network that is able to reach out to either Mark or myself, we can very quickly identify whether, we're a good match, whether there's synergy, between a project and our capabilities here. A lot of times, just from an inquiry, you have no idea. It's sometimes very hard to understand if it's a good match and if we have the capabilities that a customer needs. But it really is that next stage. The real interaction is that next stage interaction where they talk to one of us. We set up meetings routinely. We give a lot of free consulting, to folks with those first interactions. We give invaluable information and advice in terms of, what aspects of their design, will play well with, our capabilities here and what challenges there will be. We're completely open and honest. There's no reason not to be, in our interactions. And, we tell them the risks of what we're doing, and we can very quickly give them an idea of how much it costs, to have a given, process done. And it's just, there's no automated way of doing that. It's all about conversations. And when they come to TAP and they interact with us, they're not interacting with salespeople. They're interacting with, either the engineers and managers that are either running the facility, managing projects, or in many cases we'll organize meetings with the actual engineers that are going to be doing the work. That we do packaging both at Albany, and here at TAP in Rochester. So packaging isn't limited strictly to TAP. And we work very closely, with the Albany team. And one of the advantages of working with us is you're working with people that are part of the same team that's making the wafers, that's doing potentially some of the heterogeneous integration type of things that are going on in Albany, as well as, the capabilities they're working on here. And one good example of that is that we're developing a die-to-wafer hybrid bonding process. And the interesting thing about that process is that it's not as generic as some of the other interconnect technologies. You actually have to have very, very, very accurate control of the source material coming out, the nature of those surfaces and how it's been processed. And you have to have, and those materials have to transfer seamlessly and very cleanly, to another location in order to actually have this bonding take place. And at TAP, one of the advantages of TAP is we also have this what's called plasma dicing capability, which is going to be essential for this die-to-wafer hybrid bonding because it's so sensitive to cleanliness. The fact that we have a completely dry, particle-free way of singulating chips is going to facilitate this development. And so the idea is that making use of the $15+ billion fabrication facilities in Albany, facilitating the treatment of those surfaces, the clean and, seamless transfer, to the Rochester group here, and then being able to complete that process with the integration of the team in Albany to the point where we can, offer a successful, result to our customers in terms of a future offering is a good example of why that's full flow AIM Photonics all the way from, PDK development through to a working device.
Well, I think it's pretty clear that TAP is not just a technical resource, but a strategic enabler, moving innovation through the development pipeline and bridging gaps between concept and scalability, production, and integrated photonics. We have a lot of great information on our website, and it's been great learning more about some of our areas of AIM Photonics with two of our experts, Chris Striemer and Mark Wagner. Thank you, everyone, for tuning in, and we look forward to bringing you more conversations that spotlight the advancements shaping the future of integrated photonics.
Thanks for joining us on Photonics in Focus. Be sure to subscribe and stay tuned for more deep dives into the latest advancements with industry experts throughout the integrated photonics ecosystem. For more information about AIM Photonics and the work we're doing to advance the integrated photonics industry in the United States, please visit our website at aimphotonics.com.